Hi, I'm Mr. Friends. Let's take a look at how to solve a problem like problem number 1 on today's quiz. In this problem, I have 85 grams of antimony, that's chemical element SB on the periodic table, at 95 degrees Celsius, and it's added to 300 grams of water, which has a specific heat of 4.186 joules per gram degrees Celsius, and that water is at 5 degrees Celsius. What is the specific heat of antimony if the equilibrium temperature is 6.26 degrees Celsius? So the equilibrium temperature, that's the final temperature after they've been added. So the first thing you should do is write all the information down that you know. You should always do this unless you've done this problem 100 times. And even if you have done this kind of problem 100 times, writing it down is still helpful to avoid mistakes. So what we're going to do, we're going to solve this problem, Q equals MC delta T for the antimony, and then also Q equals MC delta T for the water. Now, we know that the heat going in and the heat coming out are the same. The heat coming out of the antimony is the same as the heat going in to the water. So these two things, Q, are going to be the same for both. But I'm going to set one of these negative. So I'm going to remove these Q's, and I'm going to say equals, and then I'll just throw a negative sign in there because we want these two sides to be equivalent. So what do I know? Do I know these? So M for the antimony, I'll write SB here, is equal to 85 grams. C for the antimony, SB, that's our unknown. And delta T, well, I need to solve for delta T. So that's equal to TF minus TI, which is equal to, we said our equilibrium temperature right here is 6.26 degrees. So that's 6.26 degrees Celsius minus our initial temperature of 95 degrees Celsius, which means that delta T for the antimony is going to be a negative number, and that works out to negative 89.74 degrees Celsius. Now on the water side, the mass of the water, which I'll write down M sub W, is equal to, it says right up here, 300 grams. And the C, we know for water, is equal to 4.186 joules per gram degree Celsius. And the delta T for the water, well, that's going to be equal to the equilibrium temperature, 6.26 degrees C, minus the initial temperature of 5 degrees C, which means it's equal to 1.26 degrees Celsius. Now we've got all of our information pulled from our word problem down below so that we can start substituting these values. I'm going to substitute everything I know into this side and everything I know into this side, and then we'll see what we get. So I have 85 grams of antimony times C, which I don't know, times a negative 89.74 degrees Celsius, and that's equal to 300 grams of water times 4.186 joules per gram degree Celsius times 1.26 degrees Celsius. Now, the easiest way to solve this problem for C is to just divide both sides by 85 and by minus 89.74. Oh, that minus reminds me, I was going to stick a minus in over here, and it's going to cancel with that one. So if I divide both sides, I say I'll put my 85 grams, okay, divide both sides, so that cancels. So I got my 85 grams here, and I'm also going to divide this side by minus 89.74 degrees Celsius, so that cancels. I'll do that over here, minus 89.74 degrees Celsius, and my minus signs cancel out. Remember, I had a minus up here, So this minus sign is going to cancel with this minus sign, and they're going to become plus signs. So now I just pull out my calculator right here, and I'm going to plug in all of this after I clear it. 300 times, well, let's try it again. 300 times 4.186 times 1.26 divided by 85 and also divided by 89.74. Remember, both of these are on the bottom, so we need to divide by both. Divide by 85 and then also divide by 89. And when I hit the enter button, I get my value for C. That's the only thing left. C is equal to 0.207. And let's take a look at our units here. We have grams on top and grams on bottom. We have degrees Celsius on top, degrees Celsius on bottom, and all of these joule per gram degree Celsius, they didn't cancel. So joules per gram degree Celsius, and that's how we calculate the specific heat.